by definition, or from before, we know that r dot is negative omega tilde r, correct? What is omega tilde? Anybody who remembers what is omega tilde?
Matrix form of
Skew-symmetric matrix corresponding to the three components of omega, right? To give me three components, I can turn this into a matrix. In particular, it's a skew-symmetric. Okay. So we're saying omega has a magnitude phi dot, and direction is given by E. So the three components can have phi dot as a common factor, right? So you can always take phi dot as a common factor, and then the tilde operator will be carried over E hat. So this is the skew-symmetric matrix corresponding to the three components of E. E is a unit vector, okay? And I have R here. Any question about that? Any question about that? So this is dr by dt and this is d phi by dt. I am gonna construct the following equation, which is dr by d phi. So simply I cancel the dt together. This is equal to negative E tilde times R. Any questions so far about this red statement? I'll give you some time to write. Any question?
Now we have made this E as the matrix, skew-symmetric
E
matrix.
tilde, yeah, is a skew-symmetric matrix
From the
corresponding
eigenvector.
to the vector. You know, given any vector, you can construct a matrix out of that. Skew-symmetric matrix.
And what the R represent in the graphic?
What R represents in
In the graphic.
in the graphic?
Yes.
Yeah, R is the rotation matrix. It doesn't. You cannot see it on the graphic. Right?
Yes.
R is the matrix that transforms any vector from the older frame to the new frame. Right? Yeah, and we are always interested in how we're gonna write our R and how this R gonna evolve due to some angular velocity. Okay.
So, question for R dot. R dot isn't, do we usually take R dot as
With respect to time.
oh, right.
That's right. dr by dt, and we have also d phi by dt. So we kind of we cancel dt together. Yes.
The derivative is r dot or is r? That's right. The right thing.
This one is dr by dt. And this one is d phi by dt. So I kind of canceled the dt together and got d phi here. Yes, Richard?
Is that just a single rotation, or do you have, because you could have three rotations that do the same thing?
Yeah, it doesn't matter.
So it's one or
Yes. Any general rotation matrix. Okay, this is a differential equation. I don't care if down here is t, x, t, I don't care, phi, whatever. This is a differential equation with respect to a scalar called phi, dr by d phi, dy by dx, I don't care. And it's linear in R, right? Anybody can give me the solution?
Exponential.
You have x dot equals ax. What's the solution of this guy? Exponential, right? So e to the a
X.
t and this t, which you are differentiating with respect to. So here the solution of this linear differential equation is simply exponential of what? It was the exponential of the coefficient of your variable, which is negative e tilde, multiplied by whatever you are
Phi.
differentiating on. Exactly, phi. And can you tell me what is phi e tilde? Phi e tilde, what's that?
R.
Phi e tilde is simply gamma tilde. So R is negative, exponential negative gamma tilde. So, in this representation of the attitude of a rigid body, we are representing it by three components of an angular possession vector. Okay, these three components has a magnitude phi and direction n. Okay. Out of these three components, like any vector, please construct a skew-symmetric matrix called the gamma tilde. And do the exponential matrix of that, you get your R immediately. You know there is a command in MATLAB called exponential matrix of give it whatever. Okay? This is in MATLAB is written like this. So if you want to do it for negative gamma tilde, it's x of m negative gamma tilde. Okay? If you want to compute it in MATLAB. So this is our representation. R is represented by gamma tilde, so it's simply exponential negative gamma tilde. R is represented by the three components of gamma. Okay? So if you have three components of gamma, make the matrix out of that and take the exponential of it. You get R immediately.
What's the E would be the eigenvector, and for gamma we need this I as well.
Say it again, please.
For calculating this gamma, we need to have E. E will be the eigenvector of that thing, corresponding to the eigenvalue.
This is another story. We'll talk about it now.
So how we are going to calculate this R, this gamma tilde?
This is, like I said, this we're gonna talk about it later. Right now, the first line is concerned with if you have your variables, how you construct the R, right? Over here, this was really trivial. Why? Because my variables were simply the entries of R, so just put them. Over there, the variables were three angles. This was not trivial. We spent half a lecture deriving the rotation matrix in terms of the three angles, right? Now, I'm saying that my variables are three components of gamma. Okay, if you have them, how are you going to write your R? Here is the equation. Okay? What's the next question that we usually need to answer?
How the R evolves.
Well, you start initially with some gammas corresponding to some rotation matrix or corresponding to some attitude, and then you do a maneuver how these gammas will evolve with time. Right? So I need something like gamma 1 dot, gamma 2 dot, gamma 3 dot, or in general gamma dot. This is trivial. What is gamma dot? What's gamma dot? Yeah, this is trivial indeed. Okay? Any question? So, I think we can just carry this over. Anybody needs these details? Can wait for you guys. Anybody needs these details? Okay. So I just need this statement, which is R equals e to the negative gamma tilde. This is exponential of a matrix, so if you want to write it exactly, this is I identity minus gamma tilde as a matrix, plus gamma tilde squared over 2, and so on. So, of course, gamma tilde squared is gamma tilde multiplied itself. Gamma tilde is a matrix, don't forget that. Okay, so this is matrix exponential. That's perfectly fine, and this works for any dimension. If you have, we are talking about three-dimensional rotations, but this definition actually works in any dimension. If you have gamma as a 9 by 9, you get the 9 by 9 type of thing. Okay? But in particular, we're interested in the 3D. This formula, exploiting the 3D nature of it, and the nature of gamma, you can construct R as follows. Cosine phi times the identity minus sine phi times the e tilde plus 1 minus cosine phi times the matrix determined by e hat transpose. So this is a nice formula that if you have gamma, gamma has three components, its magnitude is phi and its direction is e hat. If you have the magnitude and direction, you can simply construct R from this equation without matrix exponential. We don't care now because matrix exponential is very easy using MATLAB. Any question? Remember, E hat is a column, right? It's a vector. It's a column, and this guy is a row. Column by a row gives you a matrix. Any question, folks? Yes, Jeff?
So cosine of phi, is that
Yeah.
the matrix times cosine
Sine
of
phi
y?
times is identity, I'm sorry. This is a matrix.